Calculate the position of C with respect to A, RC/A, which is equal to 0.15 J. Because of the clockwise rotation, then VC is pointing to the right. This is a rotation case, therefore VC is equal to omega AC cross RC/A. Omega AC is negative because of the clockwise rotation. So after calculating the vector cross product, we have VC is equal to positive 1.5 I meter per second. This is true because VC is pointing in the positive direction of x-axis. The next step is to focus on another rotation part of the mechanism, which is the wheel BD. Start with the position vector RD/B, which is pointing to the left, therefore it is equal to minus 0.1 meter. Omega BD rotates in counterclockwise direction because the velocity VC is pointing to the right. This means that omega BD is equal to positive omega BDK in unit vector form. Due to the counterclockwise rotation, therefore VD is pointing downwards. VD is equal to omega BD cross product RD/B because this is a rotation case. Now we have calculated both rotation part of the mechanism. Now we move on to the general plane motion part, which is the rod CD. Calculate the position vector RD/C, which is equal to 0.6 cos 30 degrees I minus 0.6 sin 30 degrees J. Now what we want to do is basically to calculate the velocity of VD based on rod CD. This time we need to use the general plane motion equation, so VD is equal to VC plus omega CD cross product RD/C. We're gonna assume that omega CD is positive. We have already calculated VC, so substitute that value in this equation. Now if you notice, we have two equations that represent VD. So what we're gonna do is basically to solve these two equations. So we make equation 1 equals to equation 2. Rearrange those with variables on one side, those without variable on the other side. Then you will group the equations into I and J component. You can already solve the first equation to get omega CD equals to minus 5 rad per second. Substitute this value in the J equation to get omega BD equals to 25.98 rad per second.